Hello, my name is Maralbek. I'm a data analyst at Urban Big Data Center, and today I'm gonna show how to install and run YOLOv4 custom model on Ubuntu 18.04. So, what is YOLOv4? YOLOv4 is highly accurate and fast object detection model. If you want to know more information about this model, you can find it in this paper written by Alexey Bachkovsky. So basically here you can find its performance on the Microsoft Coco object detection dataset. Also you can find the information about its architecture, and here in the Alexey AB GitHub page you can find more details on YOLOv4, like its source code, and I believe you can even find the YOLOv4 model zoo. So basically from here you can download the pre-trained models which are capable of detecting more than 80 object classes. So for instance, if you need the classic YOLOv4, you can just click this link. If you need, I don't know, the tiny version which is faster, you can download that one depending on your needs. So and now I'm gonna show you what YOLOv4 capable of. So this is the video which was run through the YOLOv4 model. Yeah, and this is the custom YOLOv4 model which me and my team have trained here at the Urban Big Data Center. You see, it's capable of detecting cyclists, pedestrians, cars, and if you run this on GPU, the model is capable of processing the video in real time. The video is 25 frames per second, so it is pretty fast. Okay, so now I gave you a brief background of the YOLOv4. We can start installing the drivers. So just to wrap up of today's tutorial, first I'm gonna show you how to install the GPU drivers. So basically there are two ways of running the YOLOv4 model. You can do it either on CPU, which is much slower, or on GPU, which most researchers and other enthusiasts do. So yeah, I believe that the hardest part of running YOLOv4 on GPU is correctly installing all of the drivers. So we need to make sure that the Ubuntu, CUDA and cuDNN versions are compatible with each other, and today I'm going to show you how to check this. After we have our drivers installed, we will also download the Darknet framework to run the YOLOv4, and after we have our drivers and the framework, we will just process the video I just showed you, and hopefully we'll get the same results. Okay guys, if you're ready, let's go. So before we begin, we need to make sure that our system meets the following requirements. So I'm using Ubuntu 18.04 and I'm gonna install CUDA Toolkit version 11.0 and NVIDIA cuDNN library version 8.0.5, NVIDIA driver 460, and I'm going to use Python 3.8. So now I don't have the NVIDIA drivers, but if you guys already have CUDA and cuDNN drivers installed, you can skip this step. But now I'm gonna show you how to actually install them, but because this process is not straightforward. Okay, now I have my terminal open. So, in the very first step, we're gonna check if we have NVIDIA drivers installed or not. So, on this PC I don't have anything installed, so I expect this output. So it says that NVIDIA SMI not found. And before installing them, I will need to install some dependencies. And I'm also gonna upload this tutorial with all of the codes along with my video to make sure that you have everything to do this, to repeat this on your computers. So okay, I'm gonna install these dependencies, password, okay, yeah, okay. The next one, I need to run this one to add the CUDA repository to my computer. So I'm running these codes. Okay, I'm pressing enter. Okay, now I need to update my packages. Okay, they will give me some errors, but they are not related to this CUDA. And okay, I'm gonna install YOLOv4, but before installing it, I need to check the compatibility. So since I'm going to use CUDA 11, so as you can see here, NVIDIA driver 450 is fine. So everything is here on the NVIDIA website. I'll give you the links as well. So what we're gonna do now, we're gonna go and install this. So I will copy this command and paste it. Okay, it will take some time. There are some errors, some warnings, but they shouldn't affect because I've done this before. Okay, now we need to go to our home directory. So okay, we can just, yep. Okay, you see here we're going to our home directory, and then we need to create the folder. Okay, we have created that folder. Then we need to go inside that folder. Okay, we are there, and after that we need to install the CUDA. First we need to download it, but so I'm going to show you from where we're taking it. So here on the developer NVIDIA you can find this, the CUDA toolkit archive, and I'm going to use this version because this is a version I have already used and I tried many times and it is working. But if you guys want to use the newest version, you need to go and check for this compatibility, okay? But as I said, because I have already used that version, I prefer to stick with it. So I'm gonna go now. So yes, I'm using Linux. My architecture is this one, and I'm using Ubuntu. It is version 18, and I'm going to use this local. So as you can see here, yeah, this is what I need to download. So I'm in that folder and I'm downloading it. Okay, it's being downloaded. So if we go to this home directory, and yeah, we have this folder, and as you can see, it is being downloaded here. Okay, now I have downloaded this file. Now I just need to go here and copy this and just go and install it. Yeah, I think it also will take a while, but here are some important steps which I need to show you, so you need to be patient here. Oh yeah, okay, so here we need to accept this one. Do you accept above EULA? Yeah, so it's basically end user agreement. Yeah, so I am accepting it. So what we're gonna use, yeah, we need to check here. We're using CUDA 11. We have our driver for 50. Yep, so we go ahead and install it. So okay, for some reason this time it didn't let me install it this way, but it is not a big deal. There are other ways of installing it. So basically, now I tried to do it through the run file, but now I will try to do it through the dep file. So what I will do now, I'll just come back here. I don't need this one. I'll just move it to rubbish bin, and I will just follow these commands. So basically it's exactly the same steps, but instead of using a run file, we're using this file. So I'm opening my, okay, now it's downloading. Oh, it's already downloaded. That was pretty fast. Okay, now we need to move this one to another directory. Okay, now we need to download this one. Okay, yeah, this one, that takes a while. So okay, we have downloaded this deb file. Now we're gonna go forward and depackage it. Okay, it's unpacking. Okay, and after I unpacked, I need, yeah, okay, it's been unpacked. Now we gonna, okay, it says okay. Now we just need to update all of our packages. Okay, some signatures couldn't be verified, but it is alright. And now we're gonna go ahead and just install CUDA. So okay, after I have installed the CUDA drivers and rebooted my computer, now I can go to terminal and run this command NVIDIA SMI and check. Okay, so as you can see here, everything is installed. Now we have driver version 450 and CUDA version 11.0. Okay, so after we're done with this step, now we're going to install the cuDNN library. So in order to download cuDNN library, we need to go to this website. So if I go and copy the URL and then paste it here. So what we need to do here, I have already created an account there, so you need to create an account and download the suitable version. Since I already have an account and I logged in, so I'm not going to download the newest versions. I'm gonna go and install version which I'm using successfully. So it was version 8, yeah, since we have CUDA 11.0 and I was using this version cuDNN 805 for CUDA 11.0. So I'm gonna go ahead and select, yes, so since I'm using this Linux this architecture, okay, it started downloading. Yeah, as you can see, there are many options, but since I'm using the Linux machine and this is the architecture I use, I'm gonna go and download this one. Okay, show downloads. Okay, as you can see, it's being downloaded. Okay, it is downloaded now. So what I'm going to do next, so okay, let me just copy these and paste it into my installers folder. So here's my installers folder. I'm gonna go ahead and paste it here. So what I need to do now I need to unpack it. So I'm gonna open the terminal. I'm here now. So I need to use this command. Okay, now I will copy the name of the file. So it is this one. So I'm gonna copy its name, I'm gonna paste it here, and also I need to use this command. So I'm gonna go ahead, paste it here, put the space, and then run this command. Okay, as you can see, this folder. Okay, now I'm unpacking. Okay, it's done now. So what is the next step? Now I need to go inside that folder. Okay, I'm inside. So basically, go inside. And now I need to copy all the contents of these two folders and paste it into my CUDA directory. So what I'm gonna do, I'm gonna go ahead and run these two commands. So now I need my terminal. Oh yeah, because I'm already in CUDA directory, so I don't need to type in CUDA here. So I'll just get rid of this. Okay, and so yeah, and same here, I don't need CUDA here, so I'm gonna go ahead and copy. Okay, it's being copied too. So okay, so here we're done with installing the CUDA and cuDNN library to our computer, and the next step is going to be to install the OpenCV. It's another library which we'll need, and then go ahead and install Darknet and run our model. So in order to install OpenCV, yeah, there are like many different methods, 3 at least, but I'm going to use this one, the most straightforward one, because you will basically just copy this one line and install it. So it's Python 3 OpenCV. So OpenCV is an open source computer vision library, and I think I guess it is needed to draw that bounding boxes in the video I showed you at the beginning. So basically this library is like really convenient if you need to play around with images or videos. So basically, since I have already OpenCV on my computer, now we're just gonna go ahead and check if it is installed properly. So I'm gonna open the terminal and go ahead and install Python 3. So now I have it here. I'm in my Python IDE, then I'm gonna import CV to SCV and print its version. Yeah, so this is the OpenCV version we have here, and it is installed. So okay, after we have all of our libraries, now we can go ahead and download this Darknet framework. So I'm going to their GitHub page, copy this one, and just say git clone. So you see, now I'm here. Darknet, I'm going to the Darknet directory. Here you see there are like many different files. So okay, I will close other terminal windows which I don't need anymore. So I'm now here inside this directory, and before installing it, what I need to do, I need to open this make file and I'll make some changes there. Okay, it's keep asking for my password, but it is fine. So as you can see here, we need to change this one, GPU to 1, cuDNN to 1. We didn't have to 1 because in OpenCV to 1, because this is the libraries which we need. So for instance, if you don't want to utilize your GPU and want to run it on CPU, you need to keep these three as zeros. And also one thing that we need to change here is to select the right architecture. As I'm using RTX 5000 NVIDIA, so here, depending on the model, you need to select, I believe it is this one, the architecture that I need. So I'm gonna go ahead and uncomment it. So, but I'm gonna show you. So we can just check it here. So we need to NVIDIA code architecture. Yeah, and so you see there is a table. I'm gonna write that I using RTX 5000. Oops. So I need, yeah, this one. So my quad RTX are 5000 and I'm using CUDA 11, so it fits here. So I need this one, 75. So yep, I'm right. Now I'm gonna go ahead and exit, Control X, and yes, we need to save it. Make file, yep. So that's it. Now we need to go ahead and run the model through the video. So after we made the change to that file, make file, we just need to go ahead and make it. Yes, so it is done. So I just run that make command. Okay, so now, yes, so what do we have now? Now we have an executable file called darknet. It's here. Now we can go ahead and run it on a video file. So basically this is the command which we need to run it on a video file. So I'm gonna open my terminal. So since this command is for the parent model, for the pre-trained model, but as I told you in the beginning, we're gonna use our custom model. So this is the YOLO. Okay, I'm gonna go and rename it into the custom model, YOLOv4 custom. So this is the model, this is the configuration file. This names basically tells you what are the objects the model is capable of detecting. So here my customized model can detect these 9 objects, but the parent model is capable of detecting 80 different types. But the main difference, the main reason why we trained this model, because we wanted to detect the cyclists. So as you will see in the video, our model is quite good in detecting cyclists compared to the parent model, which can only detect bikes. Whether it is like just a parked bike or I don't know, just a single bike, whereas our model can detect when the bike is being used or not. So this is the main difference. Okay, this is not that important. Then we have this object data. Yeah, this is also we need. So basically here, what we need to do first, we need to give it the directory to this names file. This is the most important thing here. It's here. Then we just need to say it's object.names. Yes, classes is 9, and this too it's needed when you're training the model. so we don't care about these tail lines. Okay, I have saved this one. We have our configuration file. So what we need to do here? So configuration file. Okay, first is this data. Yeah, I think we can just go ahead and say this is here. I'm gonna just see this. It was not calculated, it was called the object data. So this is the standard command which is used on that GitHub page I guys showed you. So now we need to give it direction to this weights file. Oh no, first we need to do this direction to this configuration file. So I'm gonna delete this one, give it direction, so it's called YOLOv4.cfg. So this is all correct, and now we need to give it to the weights file. It is actually the model itself. I'm gonna go ahead, so it is called YOLOv4 custom. So we just need to edit it is the custom weights, and finally we need to give it directly to that video file. Our video file is here, is this one, UBDC MP4, but we can rename it. So I'm gonna just open it with this VLC media. I'm gonna show you. This video is lagging a bit because I'm connecting remotely to my Ubuntu machine. That's why it's a bit lagging. So basically we're gonna take this video and then we wanna rename it. Let's rename it to the input rename, and yes, so I'm gonna need to give the output, so we need to give it file name, so it will be, so it is so it's YOLOv4 tutorial, and yeah, it's in this directory. It's called input.mp4, so I need to say input.mp4. Oops, mp4, and I'll just leave it there in that directory, and I will call it output. So hop. I believe it is stored as in the AVI format, so I'll just go ahead and use the output AVI. So okay, now we have our command here. We can go ahead and open this. So you see it's in darknet directory. I'm gonna run this command. So we have detector, demo, everything here. I'm gonna go ahead and run it. Yeah, I believe. What it says here? Couldn't open the file. Oh yeah, there's again some stupid mistakes here. So you see I have weights without weights 2 times, so I need to I have it. Actually it's supposed to be custom, right? YOLOv4 custom. I don't know, it's lagging a bit. Let me just check. Yeah, it's called YOLOv4 custom. So YOLOv4 model, YOLOv4 custom. Okay, and now I think now it should be right. Okay, I think it will take a while for us to run this one, but I'm gonna stop it now and I will show you the output. Okay, so now after YOLOv4 finished running the command, we can go and see that output file here and open it. Open with other application, and here is the, yeah, this is the output. Okay, so this is it, guys. Thanks for watching and see you in the future tutorials.